my zone.
No.
No.
I was joking, by the way. So is ether connected to the electric universe? Like I used to think the electric universe type people were wrong, but the more I think about it, I've always known that, electricity and some type of, I think that has to do with ether. Am I wrong on that? How it conducts?
Well, Tesla would agree with you on that one. Okay, before you go on, a clarifying question. Because you said quantum physics, right? So were you able to incorporate gravity into your grand unified theory? So how did you explain? Hold on. How did you explain gravity? Yeah, but hold on, bro. Now you're meshing two theories now. You're meshing the ether with quantum mechanics. Those are two different things. I mean, how? I don't get it. Okay, you can ask the question, and what's the answer? Okay, question. Obviously, you think the ether flow on the Earth is on a flat. You envision a flat thing, right? A plane, let's say, right? So there's one direction of the ether flow. Because I'm going to ask you then, how do How does that square on the moon where it appears to be spherical, let's say? How would the ether flow in that?
GG.
Okay, so how would you envision the ether flow, let's say on a plane or on a sphere? How would that work? Okay, so okay, so which direction is the flow in your sphere? Are you saying it flows to the center all around? Yeah, but I get you, bro. I get you. But this flow of yours, right? It's flowing in all directions. See, that's like a problematic thing there. If you have a sphere and you want to say that the ether is the cause of gravity on a sphere, right? The push of it. How is it pushing? Is it pushing in all directions? I mean, flowing. Yeah, it's kind of fascinating because you're mixing up two worlds, right? You're mixing up the ether world with the quantum foam world, which is okay, but I just never heard it like this before. So I'm trying to make sense of it.
I was having a mic issue. My bad, man. Keep going. Sorry. I was listening to you on Sean's stream. You know, Lil Sean G. Some guy was telling you that mainstream believes that causes don't. I can't believe I'm even about to say this. He said causes don't precede effects. I'm wondering how you didn't really acknowledge that. I'm wondering that was like it's like an easy win right there. Why didn't you address that? I know, but if bro, somebody said to me causes don't precede effects. Like that's not gonna just breeze by. That's like it's like crazy.
We all know 1 + 1 = 11.
Globe hamsters. Globe gangsters. Gangsters. That's it.
That's surprising.
I'm appalled. Yeah, I'm appalled because honestly, Mordwan, the owner of that server, was fighting one day. I heard a debate. It was on Jeranism, as a matter of fact. He was arguing for your thing. Ether and general relativity was ether. They were trying to mesh him and that Peter guy.
Yeah, I've got a different view of that. Well, yeah, I mean, you couldn't answer the questions. I did. I mean, yeah, they're a little harsh. I wouldn't say that they were constantly under, you were constantly under personal attack or anything, but basically all you're doing, you're accepting everything, gravity and all, and you're throwing ether in the mix and saying it solves everything when you can't demonstrate that in any way.
Yeah, it doesn't sound like the place. It doesn't sound like you'd be constantly attacked if you went to a place called Gangsters, Globe Gangsters.
No, that didn't happen to me yesterday.
No,
No, I was
I'm
just
not saying they're
imagining it.
angels. Yeah, I'm not saying they're angels, but I mean, to say you were under constant personal attack is a gross exaggeration.
By the way, in your ether, weather.
Well,
Okay.
I was in there a few times over the last days that you're talking about, and I'm hearing you repeat the same thing you said over there. So it's unbearable to hear someone repeat the same thing for 4 days in a row. Good luck with your YouTube channel.
I do. I have a question. I have a question. So you say you believe in general relativity and special relativity in your ether model. Do you have time being absolute or relative?
No, you don't believe in general relativity. Sorry, go ahead. Okay, but
No, but is time
okay,
absolute?
but how do you not?
Go ahead, sir.
Go ahead.
I don't think I got an answer.
Hold on, man. No. Me or him was gonna go. I'm gonna go then if he's not gonna go. You don't believe in general relativity though, because a few days ago you were arguing that that gravity is a force, and in general relativity, gravity is clearly not a force. So I don't know why you would say you believe in special relativity, but then say gravity is a force. No, general relativity. Mm,
Okay, but is time
It's not a word
absolute?
game. Go ahead.
I just want to know if time is absolute. I don't think I got an answer. Well, okay, what do you mean by time dilation? I know, but okay, but what do you mean? Explain to me, like as if I'm 12 years old. Like, what do you mean? The link between ether and time. Oh, yeah. Come on, man, just explain, and then I'll look at the paper. I'm not just gonna read a paper. Oh, so it's a mathematical theory again. Yeah.
While we're here, I have questions about general relativity, though. So once you get through this time dilation thing, I'm going to take over and we'll do a little general relativity, if that's cool. I don't know. Does he want to? Is he there? Hello, mic check. He may be having connectivity issues. Maybe you stumped him. He might have ran away because you stumped him.
No, sorry.
Oh no, there he is.
No, I was just sorry. I just got a call from my bad. Yeah, I do. Yeah. Yeah. I think I've seen that.
They also have a 5-sided square, I think.
That's what I'm talking about. 5-sided squares. They're the shit.
Remember, all these talk about
Heads are out here playing around with 4-sided squares like babies. You got a little baby 4-sided square.
You got to move on up, like the Jeffersons.
I know. I think I've seen it. I'll refresh my memory. But like again, fundamentally, the issue here is we're not talking about time when we talk about these waves or even the photon clock. We're talking about motion, right? Motion of something that's either slowing up or slowing down. To say that something's slowing up or slowing down has to be in reference to an absolute time scale. That's the thing. When you talk about the bending of time, it's being conflated here. When we talk about clocks, you're talking about something in motion, not time itself. Look, in relativity, they are talking about time. They're saying there is no absolute time. I don't want to get into this again because it just devolves and people start getting triggered. But in relativity, there's no absolute now. So there is no time. There is no actual absolute time. So, but if we're talking about clocks ticking, then we are doing that in reference to an absolute time. Yeah. Dude, in order to even have something slowing up or slowing down, there's a whole bunch of metaphysics that has to get baked in to even make intelligible sense of it. So you can't actually define. I know what you mean, right? I am being good faith. I know what you mean when you say you're trying to define things empirically. But in order to define things empirically, that's not like a freebie. There's a whole bunch of metaphysics that gets baked in But for a lot of people, it's like the fish in the water. They don't realize they're swimming in those metaphysical categories when they are coming up with these definitions. And that's the problem here with this whole relativity, discussion, broader discussion, not just with you, but just overall. Is there's a lot of hidden assumptions. Let's call them assumptions, hidden assumptions, but really just assumptions and metaphysical categories in order to even begin to have the conversation. It means it yeah. Well, that could be because that could be a combination of like people you not being familiar with this kind of philosophical side of things, and also me maybe not putting it in the most accessible way. But you can't define things empirically, basically speaking. I know what you mean when you say that, but you can't actually do that. Let me see. I'm not saying you can't do that. Like, I know, but you misunderstood me, so I'm clarifying. I'm not saying that. No, you did misunderstand me because you said you made it. Made it you made, yes, you did. Oh my god, whatever, dude. Go ahead. But you did. You literally said I'm a free
Yeah,
person.
let's let him finish, bro. We're doing good. Let him finish, and you go after. That's all.
All right, cool. All right, cool. Come on.
Is there such a thing as objectivity?
Okay, can I just respond because he's completely missed the point. I'm not saying that you can't do whatever you want. You can say the words you want, but it's unintelligible. It's metaphysically incoherent to say you define something empirically. Empirically just means as pertains to sense data. There's no way you can simply use sense data to define something. All definitions are made in reference, and try and follow along. And don't just talk around it when I finished, because I feel like that's going to happen. All definitions are done with reference to metaphysical categories, what we would call semantic primitives, ontological primitives. Do you know what those are? We're going to talk around it. Well, that's fine. You can have an unintelligible theory. It's all good.
Is there such a thing as objectivity, Mr. Slave?
That's not what objectivity means, but it's all good. Well, again, you're just coming up with random ass proprietary definitions. You don't understand what you're talking about. That's fair. That's fair. My bad.
Are we in the same universe? Are we in the same universe? Do you know why I'm asking these questions?
I know.
Okay, this guy is totally incoherent. Let's stop giving him the floor, please. We have too many people here that actually want to discuss things.
I kind of agree, to be honest.
Like, I don't know if he's on drugs or two different types of drugs at once or what, but he's not making any sense.
I don't want to insult him from the point.
Well, we don't have to engage with him if we don't want to, so we can change the topic.
He's just too smart, I think.
I mean, I don't know why they didn't love him at the Globe Gangsters because like I said, the Mordwan or Sea Lion or whatever his name is was actually fighting for this in a debate on debatism. He was arguing to mesh general and general relativity and ether. Should have loved this shit. This is right up his alley.
Well, it's not actually. That's. I mean, I can explain the difference if you're interested.
Isn't this what Peter and Mordwan were fighting for on that?
No,
On that
it's
debate?
not. No, what they were fighting for was what they were doing was saying you have to define your ether as something other than space time. So space time or relativity physics, writ large, makes these sorts of predictions and these descriptions of how the universe works. So if you're going to claim that ether is doing, we're going to do that and we're going to call it ether. If you want to distinguish your ether in some other way, then you need to do that, which they were unable to do.
Yeah, they
So-
were saying general relativity, this bending of space time, that bending space time thing was ether. Yeah.
Yeah, but I mean, it's not. But it's not. So what it doesn't do, what Mr. Slave is doing, to my understanding, is claiming that his rejection of particle existence somehow simplifies things. And my question was, well, how do you explain particle-like behaviors, which we never really got through, other than just to talk about like what those behaviors might be. So no, what he's trying to, what Mordwand and the other guy Peter were doing was forcing the ether guys to either draw a distinction between how they identified ether and space-time, or not being able to do it, and they weren't really able to do it. That's why I mean, that was the whole point of that, was to say, we're calling space-time ether. So if you think ether is something else, explain what it is. So no, he did not get the Mr. Slave's interactions with the people on Globe Gangsters was different. Was not people weren't in love with that because they didn't feel like it made predictions that were useful or explained particle-like behavior or things like that. My question is still about Compton scattering. How do you explain Compton scattering as a set of inelastic collisions? In a method that is, as far as we can tell, an inelastic collision. And that the energy of the system is transmitted from the photon to the electron. Not that the photon disappears, that the momentum is transferred, like a pool ball. The photon does not just vanish, to my understanding, but okay. The photon exists, but at lower energy, and it's deflected. Mhm. So Maxwell's description does not explain Compton scattering. So what you're saying here, and this is what you said before. You're saying it's a wave that acts like a particle. Well, yeah, that's what you're that is effectively what you're saying. Mhm. So so let me stop you. Here's what I would be looking for in an answer. It's not any of the stuff you're saying. Okay. An answer would be something like the reason we see Compton scattering as a inelastic collision is because the wave packet of the photon has a etheric shell around it that causes I'm telling you what I would accept as an answer, okay? Yeah. Uh
Just
okay.
repeat Omni verbatim, and he'll be happy.
So the kind of answer that I would accept would be something that tells me why the wave packet of the photon behaves like a particle. So an example of that would be in my theory there is a etheric shell around the wave packet that transfers that transfers the kinetic energy of the collision and allows for the deflection. Okay? That is, I'm not saying that should be your answer or that is your answer. I'm saying that until you can give an answer like that that explains the particle-like behavior without just going, my theory is a galaxy full of ether and everything is a wave and there's a de Broglie equation for a wave and the Maxwell equations. None of that is an answer. How do you explain the inelastic collision particle-like nature involved in Compton scattering? We're using nothing but waves. I hear you.
Bro, just answer the question, dude. He asked you a very, very specific question.
I agree that photons have momentum. My answer is I agree that photons have momentum. So, well, that because that's what I agree. That is as far as I will agree. So, I've got a call coming in. So you need to work on on having an answer to that. Actually, yeah. What's the question? Okay, I said okay. No, the answer is I don't know.
I bet you giving a yes or no to a fucking question. I'm keeping track, but you don't answer any questions. You
You're
answer
writing this
all
shit down?
questions with a question. You don't
You
ever
right?
answer any question.
He's
You writing
keeping
it down?
track.
You got a list? Yeah, list going left lane.
I'm not going to come back with an answer because you haven't answered the question that I asked, which is why the waveform. So if you're saying the wave has momentum, so it behaves like a particle in Compton scattering, that would be an answer. It wouldn't, hold up, but sure, that would be an answer you could have, or you could say, because electromagnetic radiation causes electrons to bob up and down, the wave passing through the material, because Compton scattering is from high energy waves like X-rays, it causes the electrons to bob up and down, displacing them in a manner that looks to us like an inelastic collision. That could be an answer, but you're not giving any of these answers. So, what do you mean when I come back to you with an answer? Yeah. I think you're. I think for the record, it looks like you're running away. It looks like you don't understand the question, despite me having asked you it several times. I guess haven't decided to look into it at all, and you understand that there is said to be particle-like behavior in your universe that is devoid of particles, but you don't seem to understand why that's a problem for you. I don't. Why does it matter if I answer with a yes or a no? No, no. You can explain to me what you think is going on. Okay, the answer is no. The answer is no. It does not cause an electron to bob up and down. So now I have to explain Hertz's experiment to you, right? Okay, so you could have answered the question yourself. You could have said yes, they do cause it to bob up and down, and we could have gone on from there. Mr. Slave, I gave you more of a chance than most people did. All right. I'm going to reference you because you're the guy I'm talking to. This is how we could to quote you. This is how we converse. Okay. When you ask me questions to which there is a specific answer that you are looking for, okay, you can just start with that answer and go from there. Yes, you can. Yes, you can. Yes, you can. Go ahead. Go ahead. Yeah. So we all know that the answer is yes. Okay. The answer that you were looking for was yes. So I have now drawn that answer out of you, which was tough and annoying, which is you being annoying. Go ahead.
You guys are doing that right now. You're doing it right now.
So I just want to let you know that you lost all the goodwill that I had, which was frankly a significant amount, when you told me to go away and come back with an answer, and then we could continue talking.
No, he didn't say that.
Yeah, you're not. Look, you're not going to hurt my feelings. Okay, that's not going to happen. However, when you said I had to answer you whether or not an electromagnetic wave could cause a photon or a electron to bob up and down, and when I didn't answer that because I did not consider it a good faith question, uh, you said, well, you go away and come back, or when you come back with an answer, we can continue, which I also thought was frankly was bullshit. So what you
Okay, guys, can I say something? Can I say
Yeah.
something? Because there's a lot of meta here, right?
uh, yeah.
Omni, is your point Compton scattering when a high energy wave, such as an X-ray,
Yep.
hits an electron? There appears to be scattering. Therefore, you're showing duality. It's behaving like a wave and a particle. Is that your argument?
Well, it's not my argument. Compton scattering is a particle-like interaction, right? It's a interaction that we would describe as similar to a pool ball, right? Like two pool balls hitting each other, or a pool ball hitting, a cue ball hits an 8 ball. So this is a case where the observed behavior does not match a pure wave-like interaction. Okay, so that is something that if somebody's going to claim there are no particles, there are only waves, then they would need to show how their theory explains the observed behavior of Compton scattering.
Okay, so Mr. Slave, you have a direct answer to that because we're going back and forth, and like we're either gonna solve this or like maybe move on. I don't know.
Okay, so you've asserted that Maxwell that Compton scattering comes out of Maxwell's equations. Okay, wrong. That is wrong. So you might want to look that up. It does not explain it. No. It doesn't explain the behavior. It doesn't explain the scattering angle that we observe in the electrons. You are. Go ahead and Google it. Go ahead and look at it. Go ahead and look up. All right. Yeah.
Is the truth objective?
It is not. It is not. It does not explain the angle of the scatter. So when the photon hits, its wavelength will change, right? Because it transfers some of its energy like a pool ball to the electron, and the angle at which the scattering takes place is based on the angle that it was struck like a pool ball, and that aligns with the amount of energy lost by the wave. That's not wave-like behavior. Sorry, that's not how waves work. When waves hit something, they will tend to deform around it or deform off of it. They don't reflect like a pool ball. And maybe, I mean, you might want to look into Compton scattering, and you can look into Compton scattering and Maxwell's equations if you need to, but you will discover that that Maxwell's equations do not cover Compton scattering as, one of the quantized behaviors of light.
Okay, hold on. I finally found something. Hold on, bro. So Omni is Compton scattering somehow defeating his ether flow? How about we start with that? Like like some sort of like is that it? Is that what you're trying to say, or how is it doing that? You there, Omni? I probably took a call.
He probably ran. He was shook.
Do you understand quantum mechanics? You understand quantum mechanics?
Yeah, but people keep coming at you, bringing up these problems with this. It's all a wave idea, and you don't know about any of them. So you should probably look into them and rethink this wave idea.
We got it, bro. We got it. Sorry, you don't have to repeat that part. And please try not to monologue. But I understand. I'm not putting you down. But you seem to have like I'm trying to understand your model, and I don't see one. You have like you're meshing two ideas. You're meshing ether and quantum physics somehow, and you're trying to. I don't understand exactly what you're trying to say. To be honest with you. No, it's not the questions about that. It's like I said, you don't have to me. It sounds like you don't have a coherent way to explain in a paragraph what you're talking about. You're all over the place. You're meshing ether with quantum physics. That's what I'm hearing. Well, say what you mean. Say what your idea is. Are you agreeing? Are you meshing ether and quantum physics? Is that your idea? Because that's what it seems like to me. Am I right in that? So you're doing it again, bro. You're doing it again. It's like you're going into philosophy monologue mode, which is not conducive to, like a scientific conversation. I'm sorry to say, bro.
Yeah, I mean, these guys are asking you very, exact questions, and instead of really giving an exact answer, you kind of drift off into your personal issues with scientific theories. I mean, you
This
telling
guy
us
said
about
AI.
like Essie asked you a question, are you meshing quantum mechanics with ether theory? Instead of giving a yes or no, you went off into how Einstein hates quantum mechanics and you hate it, and like is that really an answer to the question Essie asked? What are you doing? Like, what is this
Bring it
monologue?
over here. Go get your sliders on.
So kind of like string theory.
So you have a quantum mechanical worldview that only who is that?
Guys, go on mute if you're not talking. Go ahead, Nate.
So you have a quantum mechanical worldview that only involves waves. That's what you're saying. In your worldview, there's no such thing as particles, right? Okay. So now that leads us to the questions Omnivore is asking you. If you have a worldview that only has waves, no particles, how do you explain phenomena such as the Compton scattering effect or the ultraviolet catastrophe? How do you explain these in the absence of particles? Right, the ultraviolet catastrophe. How do you explain that using waves only?
You should have done a double slit, but go ahead.
Yeah, but I mean the double slit experiment just shows the wave particle nature of reality, so waves do work there. No, No. Please speak to the ultraviolet catastrophe. I was just responding to Jeremy.
So you're mixing stuff again, bro. You're mixing orbits, which are a Bohr model, and quantum mechanics, which is a cloud probability. Which one are you talking about? Bro?
Just end the sentence and say, I don't know.
I'm back.
Yeah, you should just do that, man. Oh, I mean, do you know what the ultraviolet catastrophe is? What is it? Like give it to us in your own words.
When you speak in this manner, it's clear that you can't rephrase the theory that you adhere to. It means that you actually don't
Yeah,
understand
but
what
don't
you're
interrupt
speaking
though,
of.
please. Please just let him finish. No, don't start over. Just carry on where you were, please.
Sure.
Bro, this is the lion's den. I mean, if you come out here saying stuff people never heard, they're gonna test you. Come on, man.
It's not whether we feel you're wrong. I think it's rather whether you even know whether you are right or wrong. Do you follow me? Okay.
Hey, I have an idea, guys. How about we change topics? What do you guys say? I'm putting it up for a vote.
Yeah, I'm tired of spinning in place.
I second that topic change.
Yeah, and also there's a clear difference between thinking and clutching for words in your imagination. Well,
Wow.
I'm not sure I gave you a comment.
Yeah, what did he say, Mr. Slave? What did he say?
Oh, this is going into meta, guys. This is what he loves.
Yeah.
Have you met Mr. Slave before, Riggs?
Oh
Let's see
yeah.
what you got.
We need to see the
Hold on,
victim
guys.
role play out there, okay?
Guys, hold
See,
on.
as a
second.
moderator, I
You
would
guys hear
not.
me? I'm moderating right now, Riggs.
Yeah.
I got this. Thank
There you go.
I got this. We're here. SC, what you got?
Well, I don't want to always be the one to bring up a
You're on
topic.
the spot.
Open the floor to anybody, bro. And anybody. Riggs, what you got?
How about
Riggs
that?
wanted to go
How
in.
about the vice president debate, huh? I got nothing right now, man.
I missed
walked-
that, by the way.
You know what? I watched like a few minutes of it, and it was just like, yikes. That was all it took.
What I was surprised at, speaking of debates, is when Netanyahu brought up flat Earth in his speech at the
Can
UN.
somebody post the link? I haven't seen it yet.
I don't have it, but somebody I'm sure here has it.
It just talks about the anti-Semitism within the they called it Flat Earth Society, but I feel like he was talking about the Flat Earth community as a whole.
What about the
And
anti-non-Semitism of this? This group that is making the claim.
Oh, I don't know.
See you later. It's been great.
Bye.
Later, have a good
course.
one.
The difference between being in outer space and accelerating with an acceleration g, or being in the same box on the surface of the Earth, stationary, but subject to the gravitational force, which carries an acceleration g. There is no experiment, let's put you in the box, there is no experiment that you can do that will distinguish between those two situations. Now, that is actually not quite true. The difference, of course, is that if you're in outer space, traveling with an acceleration g, then all parts of this box, including you, are accelerating at the acceleration g. If you are on Earth, then because the value of g varies according to the height above the Earth, the value of g at this point will be ever so slightly greater than the value of g at this point. And so there is a slight difference in the value of g in this situation. And if you can measure that, then you can tell the difference. That difference is called the tidal force. But apart from that, Einstein said that that was a principle of equivalence. You can't tell the difference whether you are accelerating at g or subject to a gravitational force, which is represented by the acceleration g. The second principle is that light bends in a gravitational field. This was Einstein's reasoning. If you take the person who is in the box that is accelerating through space with an acceleration g, and here is the box, and this time we're going to shine a light from this side of the box to the other side of the box. But of course, that will take a finite time, albeit small. And if this box is accelerating with an acceleration g, by the time the light gets halfway across, the box will have accelerated a little bit further forward. So it will now be here, which means the light will have reached that position there. By the time the light gets to the right-hand side, the box will, of course, have accelerated still further. And now the light, which, of course, is just going in a straight line, will reach here. So if you look at it, it appears within the box that the light has gone from here to a point lower down to a point even lower down. In other words, the overall impression is that the light has gone from here to here to here, and that's a curve. At least it should be if I've drawn it properly. So Einstein says, if that is what happens when you are accelerating through space with acceleration g, since the principle of equivalence says you can't tell the difference between that and being stationary on Earth subject to an acceleration g, then the same thing should happen in this scenario here, that light will appear to bend in gravitational. Field. Now, of course, he could have been wrong, but in fact, this was shown to be true during a solar eclipse. What happens during a solar eclipse is that the moon essentially blocks the sun, so that from the Earth, the sun, as it were, is blotted out. And what was noted from the position on Earth was that they could see a star just slightly to the right of the sun. But they knew astronomers knew that that star actually was located behind the sun, and it shouldn't have been possible to see it. And the explanation was that what was actually happening was that light from that star was being bent in the gravitational field of the sun and then coming to us on Earth, giving the impression that the star was here, when in fact the star was really here, but the light was being bent in the sun's gravitational field. Now, here was the problem for Einstein. Newton's law of gravitation, which everybody had thought had served us well for so long, says that the gravitational force is equal to the gravitational constant times the mass of one body multiplied by the mass of another body divided by the distance between them, r squared, or divided by the distance squared. And that's fine, except that in this situation here, light is bending in a gravitational field, but photons of light have no mass. So these two mass terms, well, at least the sun has mass, but the photon doesn't. So this form of Newton's law doesn't work if it is going to apply to light, but photons have no mass. So Einstein came up with a completely different approach to gravity. Instead of there being gravity, he said, actually what is happening is that all forms of motion are represented by movement in curved space-time. And I can illustrate that in this way. Let's suppose that we take a trampoline. This is the surface of the trampoline, and that's representing space-time. And we put a small marble on that trampoline. The marble will have virtually no effect. It might make a very tiny indentation on the trampoline. But now let's suppose I get on the trampoline. Well, if I get on the trampoline, with my weight, the trampoline is going to bend quite substantially. And that is the equivalent of bent space-time, or curved space-time. What's going to happen to this marble? Well, the marble is now going to fall towards me. The analogy is not brilliant, but it'll do for our purposes. Now, Newton said that that movement towards me was caused by gravitational attraction. attraction. Einstein, on the other hand, says, no, what is happening is the marble is moving along the shortest path in curved space-time. So that when the Earth goes around the sun, there's the sun, and here's the Earth in a reasonable circular orbit going around the sun. Newton says that there's a gravitational force between the sun and the Earth, which provides the centripetal force that keeps the Earth in orbit. Einstein says, no, that's not it at all. What happens is the sun being massive curves space-time, and the Earth is simply going round that curve in a straight line in curved space-time. Now, you might be wondering two things. Firstly, what is space-time? And secondly, why did Einstein think that it would be curved? Well, space-time is really just space and time, all thought of as one set of coordinates. We usually think of space as having 3 dimensions, which we represent by 3. What are called orthogonal axes. They are at right angles to one another. So we normally have the x-axis, the y-axis, and the z-axis. Or if you like, we have 3 dimensions in space, up and down, back and forth, and side to side. If you add a time dimension to that, you get 4-dimensional space-time. Problem with 4-dimensional space-time is it's very difficult to draw because we can only conceive 3 dimensions. So I'm going to cheat and I'm going to draw 1 dimension of time and 1 dimension of space, which is the x-axis. I could, of course, draw another dimension this way, but I'll just leave it as 1 dimension of time and 1 dimension of space. Now, if you draw a constant velocity in space-time, you get a straight line, because a straight line is distance divided by time. It's a constant distance divided by constant time, and that is a constant velocity. But if you accelerate in space-time, you get a curve. The reason, of course, being that acceleration means that the longer the time, the further you go. So there's a curve in the acceleration. And because gravity causes acceleration, it causes a graph which is curved in the space-time coordinates. And Einstein's view was that therefore, in some way, space-time must be curved if it is creating an acceleration which has the effect of creating a curve in those space-time coordinates. Well, that's the end of the introduction. So now it's time to introduce you to And because gravity causes acceleration, it causes a graph which is, in other words, the overall impression is that the light has gone from here to here to here, and that's a curve. At least it should.
Oh man.
I'm going to suck your zeros and ones out of you.
I mean, if you need a certain kind of blood and there's only one kind and nobody even knew it existed, and you're getting that kind, I mean, who knew? Who knows? I don't know.
It's made. It's made in where's that? Hungary or some shit? Where's Transylvania? Hungary, right?
Like, what would stop those? A 50 cal would do the trick, no? Robot dogs?
Yeah, you hit it
More than
right.
less than a 50 cal. 50 cal go through an engine block, right?
That's what I'm
They'd have-
saying. Let's say they have them
They'd
reinforced.
say a
and stuff.
357 will get through an engine block.
It would have to
44
be made of
Magnum.
silver.
You blow them up from the bottom, or you drop them in a hole.
The bullet would have to be
That's
made
what I'm
of
saying.
silver.
Outsmart them with a hole, or just
Did you see that
wires.
another drone to run into it? They take a drone and they hit a $1 million helicopter with a drone, a $2,000 drone, and kills the helicopter.
Kamikaze drones, yeah.
Why drop the dogs off at all? Why don't you just make the drone the dog in the first place and have it have the intelligence, the seeing, the targeting, the shooting ability, the gun? Like,
Well, they
It's
work
like
in combination. The drones can give intel because they have high sight, right? They can
right,
see forward. Yeah.
right. But I'm saying if you drop the dog in a hole, the only attribute they can add to that is to be able to fly straight up. So I think they would add, maybe if they're smart, some of the dogs they can hover straight up anyway to get out of a problem.
Oh yeah. Put propellers on the dogs themselves. Stop giving them ideas, bro. That's a
I'm
good
sorry.
idea, actually.
Oh shit!
Damn.
I wanted to send my Uber automatically and just make money for me. My car. Just put Uber on there and just send it out like a Tesla, and just have a camera in there. You see the person, and you have like just a little plastic thing. They get in the back. Where you going? This way. You're not even in there. You just have. There's no one in it. It's your own personal car. You just send it to pick people up, make you money while you're at work.
EM gun. It looks like a rifle, big rifle. But they have countermeasures. Jeremy just said it before. They have countermeasures. They shield it, so the drones cannot be.
Oh, you put it on the end of the bullet then. You have the 50 cal bullet, like you said, and then you put the little EM thing on the back, and you just send it out, like a, I don't know, even slingshot version to where the
1 2 1 2 1 2 1 2 3 4 5 1 2 3 4 5 1 2 1 2 1 2 1 2 3 4 5. Okay, now it's working. Oh my god. Oh my god. Wait, this is just an hour. One. It's an hour and a half ago, yeah. So this whole stream was defective. 1 2 3 4 5. Oh, wonderful. Mm-hmm. Wow.
Yeah, but now.
My right in my zone.
Mm-hmm. So
No.
mm-hmm. Just to let everybody know, this is very bad audio. My audio was not streaming. Yeah. Horrendous. Absolutely horrendous. Mm-hmm. 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 This is terrible. This means every stream needs to start with a mic check. Oh my god, what a nightmare. Every stream needs to start with a mic check. All right. Well, there's 3 people watching. Anyway, let's go back. Let's go back to these guys.
It really? Did they show like people actually? They didn't show them actually blowing up, did they? Did they have like video of it?
No.
Or they just show a bunch of people like, oh man, our pagers blew up.
Well, they don't really
Like-
want to. They don't really want to
Like,
make you die.
dude, could they blow up your phones like right now? Could they like make your phones blow up?
No.
That's what I'm thinking. Like, how are they gonna blow up pagers, man?
No,
Like
they
that,
can't
like,
blow
they're just gonna set. They just sent a really they sent a whole bunch of numbers and it just freaking overloaded and blah 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 and then just there it goes. Pagers are blown up.
I don't think that's what the process would be.
It sounds like the same crap when there was like Hamas is attacking us on paragliders. They're coming in on paragliders with AK-47s, and then you find out that Israel used footage from a Egyptian soccer team's halftime show, where at halftime these guys paraglided in with the soccer team jerseys on. So Israel used that footage and said Hamas was attacking them with frickin' AK-47s on paragliders. Oh my god, it's freaking hilarious. It's literally, you can fact check it. Like, it's one of the things that's actually like they got caught blatantly doing. You can fact check it and it tells you, yeah, no, that didn't happen.
Wait, so Are you saying that they didn't blow up the pagers?
I have no idea. I'm just saying, like how would you do that? You telling me that they figured out a way to send in enough phone numbers or whatever to somehow overload it, and then all of a sudden the pager's a weapon? Like, really? Like,
I don't think. I think most people say that they created a shell company and they ended up selling. Israel ended up selling to Hamas these pagers. So Hamas ended up paying.
oh, okay. They sell. All right. So they sold them weaponized pagers. All right, that makes more sense.
Yeah.
Okay, that's way more plausible.
Yeah. Yeah, I mean Israel, Israel is like everyone has an iPhone, and there is like in Israel you can say whatever you want. I mean there's basically freedom of expression, so you can get information from Israel. So it's not like Israel can lie. There's
Only if you're an Israeli, not if you're not an Israeli. You have no freedom. You have no access to just about nothing, actually.
What do you
Who's
mean
buying
Israeli?
pages in 2024 anyway? What was that trick? They's like, hey, you guys, you want a 40-year-old pager? Huh? Yeah, come buy these.
So
What the
So the way it happened, as far as I know, is the leader Hassan Nasrallah, who ended up, being executed, whatever, by the Israelis just last week. So, like, I don't remember, in 2006, maybe, I don't know when, or 2015, he gave a lecture, like a whatever, and he told them stop using iPhones because the Israelis can track you or whatever. So he told his organization to switch away from iPhones. So I think he started this, and the Israelis, they probably have moles. I think.
Dude,
No.
I don't believe. I swear, man. I think Hamas. I mean, everybody knows like Hamas and Hezbollah. It's all funded by Israel. Like none of it's really.
Hamas, yes.
None.
Hamas, yes.
You
Hezbollah.
think Hezbollah is real?
Hezbollah. Look, so it's complicated. I agree that Hamas was. I mean, everyone knows Hamas was created, funded, maintained, brought to life multiple times by the Mossad. Everyone knows that. That's literally headline news every time the Israelis went to Qatar. What?
Like, why does everybody believe that? Oh, Hamas is attacking Israel. Innocent women and children are being killed by Hamas. Wait, Hamas is Israel. What do you like? How does that even make any sense? It's silly.
Yes.
It's all propaganda.
No. It's confusing. I agree. It's confusing. So the Israeli government, the Mossad, definitely. It's headline news. It is the Hamas. However, so is Bin Laden. Bin Laden is ex-CIA. Bin Laden is CIA.
Right.
So,
Yeah.
But sometimes your
Al Qaeda, all that shit.
Yes. Sometimes your operatives go rogue, and you lose them. Hitler was planted by the government espionage unit into the leadership of the Socialist Party. They wanted to keep track of the Socialist Party of the Workers, whatever. It's the same story over and over again. So you plant your guy, and before you know it, you lose control, and he takes over, and you have an enemy. You scratch your head, but yeah, it happens again and again. Well, what can I tell you? It's literally what happened to Hitler. It's in his book. Read his book. He tells it. He says, I was planted by the government. I went to the meetings. I didn't think much of it, but before you know it, he became a socialist. And that's the way it is. So yeah, Hamas was definitely a creation of the Mossad, but it went rogue and it cooperated with Iran as per plan. That's basically what the Israelis planned. The Israelis wanted an enemy within, you know, so that the Israelis can cry, oh, look, we have an enemy. Oh, we cannot make peace. Oh, this is what happens when you give them a little country. They create a terrorist country. Yeah, but, you know, everything else is real. It is a terrorist country that the Mossad created. Now they have to deal with it. So they created it. Now they have to kill it. By the way, so is Saddam Hussein. Saddam Hussein is a creation of the U.S. in order to, you know, balance out Iran. It happens again and again. It's like it's life. Sometimes you have a child and your child goes bananas. You know, it happens. So it's not. I wouldn't say it's. I don't think it's propaganda or all propaganda. There's no propaganda. It's like we know all the details. Everything is known. It's all transparent. It looks like sometimes life is so crazy. It looks like we're being manipulated. It looks like a conspiracy theory, but it's not. It's just life. It's like that's how things work out sometimes. Like you'd never expect it. Basically, you could say the Mossad created a situation that is basically threatening the existence of the planet. Not on purpose. But, you know, you start things and then things have their own dynamics and you lose control very quickly. So does anybody want to talk about physics?
Physics?
Quantum mechanics, GR, SR, anything.
Is this the same guy that was talking earlier? Is this you?
Yeah.
Mr. Slave. I'd rather talk about Mossad with you. Shit.
Sure. I'll tell
I
you.
don't like talking Israel with you.
Sure.
I mean, I don't like talking. I'm not good at freaking talking quantum mechanics and like weird shit.
It's all the same. There's no difference.
Nah, man, I just don't. I don't know enough about it. I don't give a shit about it. To tell you the truth.
Anyway, look,
I'm too busy.
So
Sorry.
the way I see the Mossad creating the Hamas, this is, you know, government organizations are like so powerful that, you know, if the Mossad, the government institution makes a mistake, sometimes the planet blows up. That's how powerful governments are. That's why they're such dangerous tools, and government has to be kept in check. Before you know it, it could blow us all up. So government is very dangerous, especially these, you know, shadow government agencies that have no accountability. No one knows what they're doing. They don't know what they're doing. Like, I was reading headlines every time that the head of the Mossad, a bunch of times, the headline news was the head of the Mossad went to Qatar to pick up suitcases of cash to be hand delivered to the head of the Hamas, while the Hamas.
Guys, what are we doing? We need a topic, guys. What are we doing? We
Go
need Jeremy's
ahead.
soundboard.
There
we
you
gotta
go.
get something going. Is there? What's going on with this? But
I told him I didn't want to talk whatever the hell it was, so that was my fault. I can't do quantum mechanics. I'm just not. Can't do it, man. Don't tell me I don't want to talk about calculus either. Sorry.
How about war propaganda? Is that top on your list of interests?
What's the question?
War
Lies in the news,
propaganda.
believing lies in the news and getting hyped about it. Is that your favorite pastime?
Not really, but it's interesting. I don't know. Lies in the news. Yeah, I don't know. I don't watch enough news to really know that they're lying. I mean, really, you don't have to watch it. Just, pretty much know they're always lying. So it's a mess.
Well, I think SE's in the running to become a war general at some point in his current or future lifetimes.
Good one. Yeah, I was. I'm definitely one of those war propaganda that you call. I'm definitely into that. Yeah.
Wait, SC Montreal. Did anyone ever tell you sound like Patrick Ben David? You know that guy? Value.
No, not really. Let me ask you something. Since you asked me a question, I've been meaning to ask you, and like quick, if you don't have to answer, are you the same person I spoke to months ago, and some submission issues were involved there? Are you that same person? I won't say too much.
I can say, yeah, I'm into that. Yeah, it's probably me.
I thought so.
Yeah, I think I
thought so.
remember
Okay.
you.
All right.
Yeah, you.
Submission.
Yeah, submission. Yeah, we don't have to talk about that here. It's not relevant.
What kind of submission? Like getting a vaccine?
No.
Well,
Believing in the global Earth?
wait, like submission, submitting to freaking bitches in leather with whips, like that kind of shit.
Whatever. Not.
No, seriously, I'm. What kind? I have no idea what you're talking about.
Ask me in the private. I don't want to derail this server.
Anyways, we can move on. It just hit me like, and I go, wait a minute. But okay, cool. So war propaganda, Gio?
War propaganda is real? What did you say?
Yeah, I just don't see
No, I
how
said-
that like blends with like with the truth topics, because like how how could you validate war propaganda? And they're complete psychos and they're doing whatever they're doing with their pushing buttons and dropping bombs, but it's like the what the media gives us, like anyone's gonna believe that? Like anything the media says about war, you're gonna take that as truth, Essie, or any of it?
No, I completely resonate with your message. That's why I brought it up. Yeah, absolutely. But yeah, but the thing is, I'm not going with the media, right? I'm going with well, I guess what we get on the internet. So yeah, your point is well taken. But shall we just throw everything like it's all lies? The independent people. Stuff.
1, 2, 3, 4, 5. What's going on? 1, 2, 3. 1, 2, 3. 1, 2, 3. 1, 2, 3. 1, 2, 3. 1, 2, 3. 1, 1, 1, 1, 1. 2, 2, 2, 2. 1, 2, 3. 1, 2, 3. 1, 2, 3. 1, 2, 3. 1, 2, 3. 1, 1, 1, 1. Okay, it's good. We're good. Let's see. The effects of absorbing waves and resonance can be seen physically here. Whatever. I don't care so much. In phononic crystal waveguide. I don't care about phonons. I don't care. do. Oh wait, you can't see it. Shoot. Yeah, I don't care. Anyway, I think I'm gonna take a break. No, I'm just gonna go get some gum. I need to eat some gum. Eat gum. Gum. Let me close this thing. So we were at about here.
If you draw a constant velocity in space-time, you get a straight line, because a straight line is distance divided by time. It's a constant distance divided by constant time, and that is a constant velocity. But if you accelerate in space-time, you get a curve. The reason, of course, being that acceleration means that the longer the time, the further you go. So there's a curve in the acceleration. And because gravity causes acceleration, it causes a graph which is curved in the space-time coordinates. And Einstein's view was that therefore, in some way, space-time must be curved if it is creating an acceleration which has the effect of creating a curve in those space-time coordinates. Well, that's the end of the introduction. So now it's time to introduce you to the Einstein field equations that we're going to try to derive. And there they are. You may observe that there's only one equation, but in fact that's not true, because you'll notice that there are some indices, mu and nu, which arise in several places in the equations. Now, mu and nu represent the dimensions of space-time, 0, 1, 2, and 3. 0 is time, 1 is the x-axis, 2 is the y-axis, and 3 is the z-axis. So mu and nu can each take 4 values between 0 and 3, and the combination of mu and nu means that there are 16 variations of this equation, with mu and nu having numbers between 0 and 3. You might therefore think that there are 16 equations in 4-dimensional space-time, but in fact 6 of them are duplicates, so in fact it reduces to 10. So you are looking at 10 Einstein field equations. Now, what do all these hieroglyphics mean? Well, you'll be pleased to know that some of them you already know. You will know what a half is, you know what 8 is, you know what pi is, g is the good old-fashioned gravitational constant, and c is the speed of light. So there are only a few things that we need to sort out. First, we've got this peculiar term r mu nu, which is called the Ricci curvature tensor. We'll derive that. Then in 2 places, we've got this term g mu nu. G mu nu is the metric tensor. We'll derive that. Then we have r, but with no indices. That's called the curvature scalar, and we'll show what that is. Then we've got capital lambda, which turns out to be the cosmological constant, and we'll explain the reason for that. And finally, we've got T mu nu, which is the stress energy momentum tensor, and we'll try to explain what that is. Now, the whole point about this equation is that it balances 2 things. Everything on the left-hand side refers to curvature of space-time. Everything on the right-hand side is to do with mass and energy. And as some people have sometimes helpfully said, that what Einstein field equations basically say is that mass tells space-time how to curve, and curved space-time tells mass how to move. So here's our agenda for the remainder of this video. We've done the introduction. Next, we shall do metric tensors. Then we'll move on to Christoffel symbols, which are capital gamma terms. You may wonder why I need to do that, because they don't appear to feature in the Einstein field equation, but they are heavily involved in the Ricci curvature tensor, so we'll need the Christoffel symbol. Then we'll look at curvature itself, which will enable us to derive the Ricci curvature tensor and the curvature scalar. Then we'll look at the stress energy momentum tensor, and then the cosmological constant, and finally, we'll put it all together. You may want to take a break through this video just to collect your thoughts. Indeed, before we move on to the next section, you might fancy a break now. Okay, part 2, the metric tensor. We're going to consider a field. We could consider any field, a magnetic field, an electric field, a temperature field. I'm going to consider one of the most basic fields of all, a field with grass where the cows graze. Here is my field, and it's going to be a very bumpy field. There are hills all over my field, and here am I standing on one of the hills. And the value of the field is going to be the height above sea level. We usually give fields the value phi. And everywhere you'll agree in my field, there will be a height above sea level that I can measure. And that height will constantly change because my field is a very bumpy field. Now, how do I know where I am? Well, I can impose a set of coordinates. Here's my x coordinate, here's my y coordinate, and I am then at that position on the x coordinate, and that position on the y coordinate. It's a bit like a map reference. So I uniquely define my position, and for every position I take,
The y is in the wrong direction. The y and the phi are in the same direction. I don't think that's what he meant to do. I think he wants the y to be along this direction. The x is fine. The y is in the wrong direction. I'm gonna. Wow, 3,700 comments. Holy Jesus. This is 16 minutes. Let's see if anybody else caught it. Wow, somebody put in the work. How do you do this? Hmm. Hmm. Wow, somebody put in a lot of work. Hmm. Mm-hmm.
I can find a value of phi, which is essentially the height above sea level of my position in the field. The question I now want to ask is, how does that height change if I move a little bit? And you should immediately respond that it depends on which direction I move. The reason for that is, let's suppose that part of the field consists of a ridge. Now, a ridge is something where the slope goes down on one side and down on the other side, but along the top, it's flat. So if I'm standing on the top of the ridge and I move, let's say this is the x
He didn't close the line.
direction. If I move in the x
You need to connect all these.
direction, I go down the ridge quite substantially. But if I go in the y direction, let's say that's the y direction, I'm just walking along the top of the ridge and that's flat. So direction of movement is important. In the x direction, I would drop considerably. In the y direction, I stay on level ground. Now, how can I tell by how much the height will vary as I move along? Well, let's consider a gradient. Here is a gradient, which I'm going to call a 1 in 10 gradient. What that means is that for every 10 meters that I walk along, I will drop 1 meter. So if I start here and I walk 10 meters, by the time I get to the end, I have not only walked 10 meters along, I have dropped 1 meter down. And the way you would describe that mathematically is you would say that the change in height as I walk along is equal to the gradient, which we express as the phi by the x, the rate of change of height with distance, that's what 1 in 10 is, the rate of change of height with distance, multiplied by the distance you actually walk, dx. Let's just try that for a moment. The change in height will equal the gradient. Well, I told you what the gradient is, it's 1 in 10. And let's say I walk 5 meters, so that the distance dx is 5 meters. That means that d phi will equal 5 over 10, which of course is a half a meter. So what we've just calculated is that if you walk 5 meters along a 1 in 10 gradient, your height changes by half a meter. But this is the general form. You change in height or change in the value of field is equal to the gradient multiplied by the distance you travel. Now, clearly in my field, I'm not going to have clear gradients like this because it's a very bumpy and irregular field. But over a very, very small distance, which is why I put dx and d phi, that will be true. But as I said, direction matters. So consequently, one would have to say that the change of height, if you're traveling in the x direction, is equal to the gradient in the x direction multiplied by the distance you walk in the x direction. Or you could also say that the change in height in the y direction is equal to the gradient in the y direction multiplied by the distance you walk in the y direction, which is fine. And these two gradients will not, of course, be the same. If we were on the ridge, this would be a very steep gradient in the x direction, but there would be a level gradient in the y direction. Of course, I may not want to walk in just the x or the y direction. Let's suppose that instead of walking in x or y direction, I want to simply walk in that direction, just to be awkward. Well, of course, that is simply a combination of walking in the y direction and walking in the x direction. And in fact, we can regard these as vectors, and in my video on the manipulation of vectors, I showed that when you want to add vectors together, you do it by a tip-to-tail process. So that in fact, you take these two vectors, dy and dx, and you put them tip-to-tail. It doesn't matter which way you do it, so let's take dx is like that. Then dy goes the tip of the x vector, matches the tail of the y vector, so this is dx, this is dy, and then the resultant is the tail of the first and the tip of the last. So that becomes the resultant vector, which we call ds. And we can use Pythagoras to work out what ds is. Of course, ds squared is equal to dx squared plus dy squared. That, of course, is very simple. If you want to add the vectors together, that gives you, this is the magnitude, but for purposes of adding the vectors together, we simply say that ds, and we put a line above it to indicate that it's a vector, is equal to dx plus dy. Or if we want to know what the change in height is, we can say that the change in height as we go along the path s is equal to the change in height as we go along the path x plus the change in height as we go along the path y. But these two terms here, dx, d phi x and d phi y, we calculated up here. That's what these two terms say. So I'm going to substitute these values into this formula here. And that will give me that d phi s is equal to, now for d phi x, I'm going to replace that by the gradient times the distance. And here, I'm going to replace this by the gradient, but this time in the y direction, times the distance in the y direction. And to be absolutely proper about all of this, what I should actually write is I'm going to give these gradient terms curly d's. And the reason I'm going to do that is because that's what's called a partial derivative. It simply indicates that although this is the derivative with respect to x, there are other derivatives, in this case, a derivative in respect to y. It's not the only derivative. So it's called a partial derivative, and it's indicated as a partial derivative by virtue of having a curly d. Now I want to...
The question is, why isn't this dx the same as this dx? The answer is, I think, is because this dx and this dy are different. They're along a path, S. There's two different things here. There is the given terrain, which is phi, which is a function of x and y, independent variables. And there's a path S, where x and y are not independent, where y is a function of x. The path I'm taking has nothing to do with the terrain. I mean, the path is the path. The path there's a relationship. I mean, there is a path S. The question is, I mean, this dx and this dx should cancel. Why isn't this partial dx? So I think it's because it's an independent path. This path has nothing to do with this terrain. This is the terrain function. This is the path function. I'm independently walking along the x path, along Right, I'm taking a micro step along X. This is the contour along X. This has nothing to do. Like when everything goes to zero, there is some relationship is maintained. We don't know what that relationship is, but we don't want to destroy it. We don't want to assume that it's the same. We don't want to assume that this dx is this dx. If we assume it's the same, it goes away. All we have is d phi. And then we would say d phi equals d phi plus d phi. That's not true. We want to say d phi s, right? We want to say d phi along s is d phi along x plus d phi along y. We want to say that the s equals dx plus dy. This has nothing to do with the contour. This is one path that has nothing to do with the contour, with the topology, with the mountainous terrain. This dx, we went along x. This is by how much the terrain changed when we walked along x. This is the change in the terrain in the direction of x, and this is how long we walked along x. Right? There's some relationship between dx and dy. The relationship dy to dx is the slope, right? dy dx. There's a function y of x. This defines the path. Or you could say there is a path s that is a function of x and y, and there's a terrain phi that is a function of x and y. But s as a path has nothing to do with phi as a terrain. We want to talk about right, d phi along s. This is not just d phi, this is d phi in the s direction. And s the s direction has a dx and a dy that define the s direction. Dx and dy, or partial dx dy, I think partial dx and y are independent. Dx and y are independent. Oh, Amber.
Hey,
How are you?
I'm just really tired. Like, I can't get out of bed today. I haven't done anything. Like, I just, like, woke up and then went back to sleep, basically.
Yeah. Sometimes it happens to me. Like, I woke up very early today too, but I wanted to sleep a little bit more, and I slept more and more. It's good as long as look, as long as you're sleeping, as long as you're not, like, if you're afraid to face life, then that's a problem. But as long as you're tired, you want to sleep more, that's great. I think think that you're a cat or a dog. You're sleeping when you're tired is good. But if you're afraid, just make sure you're not afraid of life. If you are, then you should talk to me.
I don't know, there's nothing else to do regardless, but, like, I don't know, I'm exhausted. I probably have really low iron levels or something.
I see.
Ow.
Anyway, I'm happy you're here.
Thanks, dude. What are you looking at?
I'm looking at Einstein's general relativity field equation lecture notes, like a summary of Lenny Suskind's course that I had to quit in the middle because the math got confusing. So I'm trying to face my fears again. I think I have like a deep insight into general relativity. Finally, I'm able to resize it to proper space, into its proper size. I'm able to resize it into what it is. Like GR, what?
I just said yeah.
You know, it's like when you hear general relativity, you might as well hear the words magic. It's like you might as well hear magic. And then Einstein did some magic and he predicted things that no one has predicted before, and he got it right. Therefore, Einstein is a magician. But that's actually not what happened. So Einstein had some notions, and then he had access to a bunch of mathematicians who basically figured things out for him. And he, I would say, didn't even follow along. In his own words, this was overwhelming to him, but his name got attached to it because, like, he published the papers. Like, this is the ultimate. Somebody wrote my homework assignment for me, and I submitted it, and the planet ever since worships me for that.
So I guess that's what I mean when people say he didn't come up with it.
Look, I mean, no one else came up with it, so I mean, he submitted the assignment. No one else did. He put his name on it. You know, he got people to help him. He claimed he never understood it, and you know.
Wow.
Yeah, I mean, at least he was honest. It's not like he wasn't honest.
I never knew that.
What?
Sorry, I'm trying to wash my dishes because I slept in so late, but like I never had heard that before.
I mean, I don't know how serious he was, but he did say many. Like, I saw a few quotes of him saying, "I don't understand relativity. I don't understand relativity." Like, he said it. So it's not I said it. He said it.
Right.
You know, I just had a discussion with like the Flat Earth server. So one of the guys over there said that the whole war is complete propaganda because Israel created the Hamas, therefore the whole war is fake.
Oh yeah, they're 2 steps away from it.
No. So I told him, look, this is like, this happens many times in history. So Al Qaeda, what's his name from Al Qaeda?
Osama bin Laden.
Right. Osama bin Laden is ex-CIA. And Saddam Hussein is America created Saddam Hussein in order to oppose Iran. And I gave him another example. I told him Hitler himself was sent in by his government FBI, by the German FBI government, whatever, to spy on the Socialist Party because Everybody was afraid of socialists because they knew, right? They knew what happened in Russia, that, you know, it was Germany who created Lenin. Germany paid Lenin. The German government sent Lenin with gold in order to create the Bolshevik Revolution. So the German government knew how dangerous the socialists are, how easily the socialists can, anyway, they knew how dangerous the socialists are. So they sent Hitler, who was a war hero, as a government agent to spy on the Socialist Party. And he writes all this in his book, and he says, I went in, I was a spy. I went in to listen, I'm a participating member. And he started listening to what they're saying, and he said, oh, this makes sense. And he became a socialist. He became a devout socialist. And, the rest is history. So this happens a lot, that a government creates like some rogue operation some black op that goes rogue. It seems to happen a lot. It seems to happen all the time.
It does happen a lot. It happens a lot in America, and people only look at America. They
Wait,
think
what?
that other countries aren't doing it too.
Anyway, so, and then
That's part of a defense mechanism, because most of these people just want to get out of the U.S., so they think that if it's happening in other countries, then they can't escape. So they don't let themselves think about it.
Wait, did you finish the dishes?
No, I've got a bunch of them. I feel fucking miserable. I have to turn the water off in between, otherwise you can't understand me.
No, you should finish doing the dishes. I felt like you did it too fast. I don't want you to stop because of me. So you should do the dishes. I'm fine. I'll
That's
survive.
fine. I've got nothing else to do. I can smoke, and that's kind of the only thing I have to do today.
Oh, I haven't smoked in a couple of days. You know that the chick that I love the most, I sent her a text message. That not the one from yesterday, the one from
The one that like broke up with you? Or?
yeah, the one that refuses to talk to me. So anyway, I texted her.
Oh, well, my husband's home. Can you just tell me tomorrow?
Okay, bye.
Okay.
Anyway, oh, look, message. Mosine, bro, that is a partial derivative. What do you mean it goes away? It's a partial derivative. Well, I mean, what do you mean it's the partial derivative is fine, but it's a partial derivative multiplied by a whole derivative, by a full derivative, whatever you call it. It's not like I know what partial derivatives are straightforward and full derivatives are straightforward, but the combination is very confusing, right? So ds equals dx plus dy, that's simple. That's the path that I'm taking, right? I took a step in the x direction, then I took a step in the y direction. Altogether, I took a step in the s direction. That's easy, right? There is... So you would say that basically S, what would you say? You can't say that X and Y are independent variables. You can't plug in any X and any Y to get an S value. S is not a terrain. So what you have to say is that Y is a function of X, right? That's a path. What is the definition of a path? There's only very certain X and Y's that you can plug in. That's the definition of a path. The question is, can you define a spiral? In the XY plane, can you define a spiral, right? Or can you even define a circle? can you define a circle as a function in the xy plane? The answer is you can't. Not as a function. Function means a map. For every input, there is only one output. A circle, for every input, has mostly two outputs. So that's a problem. So it's not so clear. What is ds? What is it? It's a problem. It's not so straightforward. It's not that I don't understand. It's not that I don't understand partial derivatives. The definition of the terrain. Where's the definition? The definition of the terrain, I think, comes before this. Let me scroll back. Where's the definition of the terrain? This is not the definition of the terrain. Where's the definition of the terrain? Where's phi? Phi should be a function of x and y. So he never defined phi as a function of x and y, or did he? This is as close as he came to defining phi as a function of x and y. So y is in the improper direction. Y should be along this direction. The point is that in order to define a terrain, for every independent x and independent y, there is one value of phi. Phi is it's a terrain. Makes sense. So phi is easy. Phi is a function of x and y independently, and that's why the partial derivatives make sense. So any partial, like the partial x, partial y are independent, and everything is fine. But yeah. This is simple. This is phi is a function of x. This is phi. This is confusing. See, he's doing a shortcut, and now we're paying the price. So there's only d phi dx. There's no d phi dy. Maybe he'll do d phi. This is d phi dx. This is d phi in the x direction of what? Is this the terrain? This doesn't make any sense. This doesn't make any sense because phi is a function of independent x and y. So this is improper. But what does he mean by dx? This is dx. This is moving along the dx. So what does this mean? This is difficult to understand what this means. This doesn't mean anything because this sounds like I'm independently walking along x. So I don't know what this means. By how much did phi change as I'm walking along x? That's literally d phi dx. That's basically d phi x dx is equal to d phi dx. I mean, this doesn't mean anything. This is d phi dx equals d phi dx, and d phi dy equals d phi dy. So this doesn't mean anything. This is completely improper. Now he's saying, let's walk along. Okay, walking along, that's a path. That's a path function or a line function. Where is the line function? He's not talking about the line function, the path function, but he's implying a path function. He's saying there is a specific S. He said, I want to walk or a vector. He said there is this direction. Given a specific direction, so dy dx is a function of this direction. It's a very specific ratio of dy to dx that define this tiny vector, infinitesimal vector. We're defining an infinite. He didn't even say that this is ds. There's an infinitesimal vector. There's an infinitesimal vector that you can break down to dx dy, but right, imagine you change the direction of ds. Of course, the ratio of dy to dx change. Dx to dy or dy dx is a very specific ratio that defines ds, and you're saying for any particular ds, right? You want to find out right now by how much phi changes per ds, right? You're starting the discussion. You're saying, okay, let's now assume that I'm moving along an arbitrary ds on the you don't even have to say on the topology. It is implied. ds is not defined on the topology. ds is within the plane of dx and the y, dx dy, dx and x and y. So ds is defined in the plane of x and y. See, he's very unclear, very unclear. He's like, let's throw around. This is very, very short. This is complete shorthand, very unclear. And I'm paying the price. I mean, there's no point in skipping steps in order to simplify a course. You're not you're complicating it. By skipping steps, you're complicating the course. You're shortening the course, yeah, but you're making it more difficult. It's not like a shorter course is easier. This is making a shorter course much, much more difficult. Because you need to be very advanced to understand what steps are you skipping. These are very confusing. These are the most confusing steps that you're skipping. But now I think I have a hold on this GR thing. I'm beginning to understand the simplicity of GR. I'm beginning to understand how much GR is not saying something of any deep meaning. GR is just taking the postulate of GR, which is the equivalence principle, and building a mathematical framework, a mathematical tool that expresses the constraint of the thought experiment of the Einstein equivalence principle. Fascinating. Let's go back to this server. Let's see if they say something of any interest.
You can pick the curriculum. Nobody is forcing you to exact school. And also, as I said, it depends a lot on the country. It depends where you are. Not all curriculums are the same. Not everyone talks about sexual topics like you said.
Right, but right now, there's pressure, right? Because the mom has to work, the dad has to work. Not everybody can afford to put their children through private school, dude. You're talking about $30,000 a year conservatively, bro. I don't got that money, dude.
Right.
I would love to
So-
choose the school of my choosing for my son. I can't afford it, bro. I have no choice but to put him in public school, which
so
has
again-
a government-sponsored curriculum.
That's right, and they made it that way.
You
They made it that
cannot
way, bro.
expect things to be free. Okay? You have chosen to study better and have a better job so you can homeschool your kids, okay, and not to send them. Everything is a choice. Everything is a choice.
I think your approach is a bit harsh. I think you're being a bit harsh there on individuals who are less fortunate with their finances. I think you know we've got to be very careful because that's a personal attack I see there. Yes, there are people who are less fortunate and they cannot send their children
No.
to more. Don't interrupt me now. more expensive schools. But even if you do send those kids to the private schools themselves, they're still going to be learning misinformation, because the whole world, including the private schools, are teaching that the Earth is the globe when it's not, for example. Okay? They went to the moon when they didn't. Okay? For example.
Exactly.
So, you know,
So
there's a lot of
people
things
like
going
you,
on, even in private schools. Okay? Yeah. Go ahead.
the whole thing I'm saying is, okay, is that the educational system is doing its job generally. And if you want
I think it's doing a
teach
bad
your
job.
children, if you want to teach your children extra subjects, you can dedicate time and sit with them and invest in them. You cannot blame the
Yeah. I
educational
would say
system
school.
all the time.
Yeah.
Well,
Okay. Yeah.
I mean-
I would say today, schooling is only 4 out of 10 marks is what I would give it, because it's failing. It's not actually doing the job properly. It's only setting up the children, the students.
Maybe we should restart the stream because we had an audio issue. In any case, we'll take a break and we'll be back and in greater numbers.